When I first came to development, we used to develop everything just using manual skills, manual labour. We'd have a 2D drawing from our design team, which was one designer at the time. Obviously that's moved on from there to now a very comprehensive, almost full 3D model that generates CAD data. So from the time I started in development, it's massively changed. It's a 360-degree turnaround, really. The tools we depend on most are NX and obviously Teamcenter because of the version control, etc. And we can see where we've come from and where we want to aim to. If we generate views that the craftsmen are capable of understanding, of seeing. So it's important to present that information to them in a way that they can have an effect. And they do. We're currently market leaders, and that's down to those guys having an input, down to our designers pushing the envelope, and it's a great place to be. The core advantages of Teamcenter and NX are that we can simulate and build the boat in 3D before we start. So we're making the mistakes in the virtual world and not in the real world, and we're getting solutions to problems that have been long-standing in the marine industry.
We typically start with looking at the performance of the boat. We try to forecast the NVH performance and then set up some targets and work toward those targets. In development, we look at a database of the NVH metrics available to us, and we say, yeah, this is the level of performance we want to have for a particular boat. Then we do a super extensive test period. Every of those boats stays in test for minimum of 5 weeks. For the biggest boats, it's a few months sometimes. Every Princess boat is comprehensively tested. And from my side, I use tools like LMS Test Lab and SCADA's hardware to get the most of information available.
Michael's been with us doing NVH for 3 years now, and has taken us from nothing to quite an impressive range of data that we're gathering. We're using that throughout the range to understand how the structure affects the vibration, the noise that you hear. But NVH will set the benchmark for structure, will set the benchmark for a customer's experience on the boat. Because if you're drinking a gin and tonic at 25 knots, and if you can get the NVH right, get it to the correct standard, you're now enjoying your gin and tonic at a nice, smooth, level pace without hearing the noise of diesel engines or structural or airborne noise around you.
In the past, we've relied on human nature, ears, eyes, and tried to self-diagnose. Sometimes a hit and miss formula, changing parts when they don't need to be changed. But the data that Michael collates can narrow that down to an engine part or a shaft part or a part of the boat that we can nail down and change specifically rather than scattergun an attempt.
We developed our version of a digital twin on our M-class yachts. That is going to get better as time goes on, and as we grow into the new technology, that will also backfill through the rest of the range. And of course, as we develop new product, it will become part of the process and will happen in a natural way over a period of time.